The global drive for cleaner energy is helping to revolutionize transport. But two of the worst culprits, shipping and aircraft, are still pumping millions of tons of CO2 into the atmosphere every day. Now, two radical pioneers are attempting two huge challenges to prove electric power is the solution.
We need to convince 100 million of people about the new technology, and we need records to demonstrate what's possible.
Designer Kalen wants to show that his electric-powered plane can change aviation, whatever the risks. And Arne believes his electric boat is a game changer, proving to the masses that battery power is the future.
Do it full electric. Do it to show the world.
Arne Kloppenberg is an innovator with an electric dream.
I have a passion for electric power, and I think that's the power that can change this world.
Arne's childhood was spent between his native Holland and the US. After moving his young family permanently to Amsterdam, he decided to concentrate full-time on pursuing his dream.
Having kids really puts things in perspective. It's going good. Yeah. We are pumping so much CO2 into the atmosphere at an alarming rate. And never mind global warming, we're getting cancer from all that goes along with pumping this CO2. High fives. For me, being part of cleaning up this mess we've made of the world that they live in, that's my daily motivation for sure.
True to his word, Arne started his venture 8 years ago from this canal-side workshop.
We're making cars electric. We're taking out combustion engines and we are repowering them for the new future where they can be emission-free and useful for the rest of life. The combustion engine, even though it has really worked well for us for about 100 years, it is such an amazingly inefficient way of moving. You know, you could really describe it as a big heater with a byproduct of movement.
It's out.
That is a work in progress. This is the finished article.
We converted this car from petrol to electric. People talk a good deal about electric cars being boring, slow, can't go far. You know, they're so wrong. This is it, man. Electric power. So much fun. It's a lot of fun. Woo!
My mission is to show that going to electrics is not about compromise. We want to do it in a form that's desirable and fun and inspirational.
To prove it, Arne and his team have been working on a very special project.
What we have here is a 1966 Ray Wright Delta. We found her at a shipyard and we restored her, and she has been the true inspiration for us showing off what electric power can do.
Arne's plan is a world first. He hopes to drive the speedboat for almost 40 kilometers, crossing the English Channel in approximately an hour, using only electric battery power.
This is a movement. We need to push the electric agenda. That kind of splash, that's bound to get some attention. On the way to your new home, the Delta.
Arne, along with technicians Raymond and Celso, are fitting the new electric motor.
Almost a bit forward. There we go. But it is in there, man.
It's a milestone. But the real challenge with the electric transport isn't the motor, it's the batteries.
The challenges that we face right now, where technology is can you pack enough energy with you for the weight that you can carry and have it go that speed for that distance? Here we have a large pack of lithium iron phosphate batteries. They put out so much power per kilo, and they last forever. You can cycle them, and they keep going. Perfect in my application, wanting to go fast and far in a short time. Celso Manaya is our battery technology expert extraordinaire. He's actually one of the handful of people in the world that has a master's degree in lithium iron phosphate batteries.
In this boat, we are putting in 48 of these batteries. They are very good, light enough that we can do a speedboat and be fast. And they can put out a lot of power, 70
kilowatts.
70 kilowatts, yeah.
That equates to almost 95 horsepower, 11 more than the boat's old diesel engine.
We're starting to hit that moment where the cost of electric goes down, the price and the social pressure on gas goes up, and we're starting to get closer to that moment where we cross. And then the shift's gonna be big. Phew! Everybody's gonna be doing this, nobody's gonna be looking back anymore.
But Arna's boat is an unproven design, built for a challenge no one has tried before.
We're roughly in the area we need to be, and then we're just gonna start tweaking as soon as we have some actual testing data.
Battery box is full.
Excellent.
Okay, motor connected, controller box, batteries. That's about it. It's a wrap.
We're gonna do a quick system check, see that the controller can read the battery voltage and gives us power to the motor. We're gonna spin the prop slowly, but see that we have full control before we take her out to the water and test her at full speed. There we go.
Ready?
Go for it.
Pull the trigger.
Pull it. There we go.
All right.
Shall we check out if we get some spin here?
Ooh, yeah.
Sir.
Hey,
Happy days. We're ready for testing. Absolutely.
It was really a lot of work, but we're almost there. It should work out.
So, tomorrow, out into the water. See if she floats.
Yeah.
That would be nice.
Over 650 kilometers south, in the small German town of Nesselwang, aircraft designer Kalen Gulgang also has visions of an electric future, not on water, but in the sky.
I have a great passion, the passion to build an electric plane for everybody. And this is a part of the energy revolution. I'm a dreamer. I was a dreamer when I was a small child. I was always dreaming of flying, and behind these dreams, you need to work very hard to realize something that's important.
Growing up, Kalen faced a dilemma. Which career path to take? Academia like his maths professor mother, or engineering like his father?
At the beginning, I wanted to study mathematics. I was good in mathematics, but not as good as my brother. And then I saw I cannot be on the top. Then I say, but if I do as engineer, I want to do something special for aviation. I found my way.
From the beginning, I was not willing to take an existing airplane like other designers are doing and trying to do it better. I always try to do something original.
For years, Kalen specialized in designing affordable, lightweight aircrafts. But to achieve his dream of making aviation greener and more accessible, he had to find an alternative to the heavy oil-guzzling engine.
The inspiration was I saw very light hang glider with an electric engine, with battery, propeller, everything weighing only 16 kilograms.
This was for me like a bang. Wow, how much is possible?
Since that moment, Kalen's been holed up in his workshop, perfecting his own revolutionary design.
So, this is Electra 1, the fuselage. The wings are not here. So we have here 3-blade propeller, carbon propeller. We have here 1 battery. The cockpit now. We have a very light seat here. We need, in order to fly electric, to fight for every gram. This is the only possibility to be successful. Everything in this aircraft is a carbon structure. Carbon is 5 times lighter than steel. You look on this panel, it's floating in the air. This small thing is an electric engine, which weighs less than 4 kilograms, can push this aircraft in the air. It's incredible. If we compare this with a normal piston engine, it's nothing. The electric power and battery is the future.
An experimental plane like this needs a special type of pilot. Norbert Lorenzen is a flying instructor and seasoned test pilot.
I teach guys in helicopter, in gyroplanes, in fixed aircrafts. It's my passion. As a child, my father is flying with hang gliders, and so it's in the roots.
3 years ago, Norbert flew Electra 1 over Venice, but the flight didn't go to plan.
A wonderful flying day. It's close to the sunset, very still air. And yes, in this moment, the engine was stopped.
The engine switched off like you switch off a light. I checked my instruments, everything was off. It's serious.
The battery and electrical system shut down, with overheating the likeliest cause, the Achilles heel of electric transport.
Norbert has only one choice: to land on water.
Coming up,
we are here in our workshop where we try to change the world.
Kaylin finds a family of engineers dedicated to revolutionizing batteries. And Anna tests the boat to see if it has what it takes to make the crossing.
Moment of truth, people. Rock and roll.
German designer Kaylin Gulgan is passionate about electric flight, but in tests, his revolutionary aircraft Electra 1 suffered electrical failure and crashed.
I cured myself looking on this video 100 times. And after looking 100 times, I now can look without emotions. I'm now free from this pain.
With the plane repaired, Kaylin has now set his sights on an even bigger challenge, a 300-kilometer flight.
As a designer, you always do mistakes. Important is to learn from the mistake. After the water landing was an important moment to say we need to redesign to make a much safer system. Having a reliable and safe battery system. It's one of the most important things.
Kaylin's dream depends on some of the best battery brains in the business. This small family company in Friestadt, Austria, is already working on the solution. These engineers specialize in developing new types of batteries to power all types of vehicles.
We love fast cars. We converted the Porsche Panamera full electric. And when you drive, you feel like Tom Cruise in Top Gun. And we love it.
With our battery technology, you can drive over 300 kilometers an hour. And the 7-gear double-clutch gearbox that's absolutely unique in the world. No one else has a car like that.
We are here in our workshop where we try to change the world. We develop every day new system, new batteries, new types of batteries. We build it up, test it, and if it don't work, we build up a new version. And again, till it works.
The team has developed a solution to one of the biggest problems faced by electric pioneers, overheating batteries.
We find out the best thing which we can control the full battery is to cool it with a liquid system. What we see here is a standard battery which is used more or less everywhere.
Today they're testing their secret coolant. First, they create an extreme battery fire.
We simulate the massive crash which can happen to a battery.
To do this, they drive a nail into a single battery cell.
Now I'm pumping. Watch out. Okay.
The sudden release of energy causes the battery to immediately burst into flames.
Everything is burning, and that's exactly what we have to avoid.
Next, to see if the coolant will stop a battery fire.
As we see now, our new unique liquid-cooled battery model, and we do exactly the same test.
Watch out, guys.
No fire pops out, just a little smoke comes up from the liquid. That happens in the plane. We are fine because we had no fire, so nothing burns.
The brothers have been working on a large battery fitted with their coolant to power Kaelin's plane.
Here you see the cells which we use in Kaelin's battery. It's a little bit bigger and a little bigger diameter than a AA battery, but it has 5 times more energy. And for example, in Kaelin's battery, we use 1,600 of these cells.
But if it's going to power Kaelin's plane, it's also crucial that the battery is as light as possible.
Kaelin told us that keeping the weights down was very important. The problem is, with the liquid inside, it's very difficult for us, really very difficult.
With the weather good, Kaelin wants to fly in just 2 days.
We really don't have much time. Sometimes people say to us, you are crazy. Why do you do this? The reason why we do that is we believe in the future, we believe in the environment. Together we can change the world.
In Holland,
big day.
It's a key sea trial for Arne's boat under electric power.
Goedemorgen.
He set an ambitious target of crossing the channel in just 1 hour.
Dover, Calais, 40 kilometers. We want to do it in 1 hour or less. Our target, guys, 28 kilowatt draw. Because right now we've installed 28 kilowatt hours of batteries. So what do you say? Can we make this target?
I think it's feasible.
Mm-hmm. It'll be tight. We got to get enough energy in and not way too much. What a lot of people have been asking me, well, why isn't it simple? You just add enough battery. So let's just load her up. You'll go across the world, never mind Dover. The problem being that the extra batteries also weigh something. It costs so much energy to get this heavy boat out of the water and moving at that same speed that even though you have more capacity, falling short. So basically, that exact sweet spot of power to weight means that you will go the furthest and hit your goal. Make it to Dover, high fives on the beach.
If the boat can reach 40 kilometers per hour using just 28 kilowatts, the batteries will last 1 hour, theoretically enough to cross the channel.
Let's take this baby out of here. We make calculations based on the length of the boat, the width of the boat, the weight of the boat, the materials involved, the speed we're trying to go, and only in real life, going out on the water, testing it, taking log files, coming back, analyzing them, can we hopefully hit that sweet spot. I'm not leaking water, so that's an important part for any boat. So today we're testing a few different things. I want to get acceleration to about 40 kilometers an hour. That's my challenge channel crossing speed. I want to be seeing what power levels I'm drawing at 40 kilometers an hour, and I want to be knowing if my temperatures of the systems, core systems, if they're stable.
Good plan.
Yeah. Okay, we're logging and live. First time we're going to accelerate. Moment of truth, people. Let's rock and roll. Basically, a speedboat on the water, it's a car going uphill permanently. There's no coasting. You'll fall back down into the water. You got to be out on a plane. You got to be basically flying over the surface of the water. So it is the most grueling, punishing environment for electric power to show what it can do, because you have a continuous power output. So it's very hard to get that power to weight and go the distance, which is why it's a challenge. So we're doing 42 kilometers an hour. Fun. There's no doubt in that. Tomorrow at the shop, we can analyze the data I have on the laptop and see if we are hitting our performance numbers. All in all, I think I'm happy.
The next day, and the critical data is ready. If the motor needs more than 28 kilowatts to get up to 40 kilometers an hour, the batteries won't last the crossing.
Can see the kilowatts draw from the battery.
Yeah.
It's around 35 kilowatts.
35, okay.
So it's higher.
Yeah, that's not so great. Now what we're seeing right now is that we're drawing more power than we want to. Let's call it, 10, 15% off of our target at the moment.
which means that we can't make it for quite an hour. After about 2 years of conceptualizing, prototyping, wheeling, dealing, and building, we've now gone and tested, and we're off our target. So I'm falling short of the cliffs of Dover. We gotta figure our way out of this hole, is what we gotta do.
Coming up, Anna has to find a radical solution to getting the boat ready.
It's the next best step we can take, maximizing the performance at some risk.
And the Kreisel brothers deliver Kaylin's battery, but will it fit?
We will see.
In Holland, Anna and the team are struggling. The boat is too heavy and draws too much battery power to move through the water.
We have to try to see if we can get some weight off.
Yeah. Put ourselves on a diet a bit there.
Yeah.
Me and the boat mostly. Whenever you're trying to reach the maximum performance, you're gonna be trading off between robustness, you know, how much punishment can you withstand, but also weight. Is the bearing housing or my fat ass? So I guess bearing housing it.
The bearing housing reduces vibration from the engine onto the prop shaft, but the boat can run without it.
So let's see what this guy actually weighs here. We know she's heavy, but I've got the instrument. 40.5 kilos, which is, you know, on 780 kilos, that's a significant amount of weight. Yeah, I think it's worth taking this one out. It's the next best step we can take in maximizing the performance at some risk of, you know, this vibration introducing stress to the shaft, which could lead to its own problems. But you're only gonna know if you're gonna do it, so we gotta try it out.
The slimmed-down boat now needs to use 15% less energy when traveling around 40 kilometers per hour, or else the batteries won't last the crossing.
So here we go. So I'm doing 41 kilometers an hour. This is my perfect channel crossing speed. She's handling real well, actually. So with a little less weight in the back, I'm going a little faster for the same RPMs. Going into home. See what the data says. There the faithful are.
Again, the boat went fast enough, but if the motor was drawing anything more than 28 kilowatts, they're back to square one.
Well, here we are. Oh, man. If I would guesstimate what our average power here is, I'm calling it about 32 and a half.
Yeah, it's between 32 and 33.
Yeah.
Looks like it.
This is, realistically, guys, I'm paddling into Dover now.
Off-the-shelf lithium batteries aren't going to be enough.
The only way out of this hole, really, is to change battery chemistry. From the start of this project, it was clear that there was another battery out there, but we just wouldn't have access to it yet. It's the type of batteries that Tesla Motors uses for their cars. Tesla pretty much have the dibs on using those batteries, and small shops don't have a chance of getting their hands on them.
Tesla and Panasonic produce batteries with one of the highest power-to-weight ratios.
The Tesla cells will give me half again the energy for the same weight as with the iron phosphates. But finding them is the trick.
But in Germany, the news is better. The Kreisel brothers are delivering Kaylin's battery on schedule, but weight is crucial.
45.5. I'm happy. Now we have to see if it fits in the plane.
It's light enough, but Kaylin designed his plane around a standard battery. With the liquid coolant, this one is bigger.
But the problem right now is the pilot seat is going in this line here. These edges are in the pilot seat.
I measure the width of the battery. Battery is 250 millimeter wide, and our opening is only about 170, so we need to cut something more.
Not much space, but we will see.
Problem solved. For an engineer, you are quite intelligent. Huh?
Yes.
It fits. Just.
When I saw the battery, it's quite big. I was a little worried, but it fits. So it was a good day.
Okay.
I'm happy. We need 2 days ground test, and then we can go to the airfield. We go to the limit.
In Holland, Arne is struggling to find the only battery up to the job of powering his boat.
We're in early days of new technology, and a lot of companies, big factories, they're going to go after the biggest contract they can. They're looking for an automotive supplier. They want to supply a Tesla. They want to supply Audi, or if Porsche is finally going to make their electric car they've been talking about, that's who they want to supply. So smaller companies doing retrofits and doing one-off projects have a hard time getting a chair on the bargaining table to buy these things.
Each week that passes, the weather in the channel deteriorates. He's been searching for days, but Arne isn't giving up.
Hey, how you doing, man?
Finally, he gets a lead.
I just did the impossible. I found a source of bona fide, honest-to-goodness Tesla cells made for Mercedes under license. They're in California, EV West in San Diego. I really, really need those Tesla batteries. So I'm gonna come over and let's make it happen, okay? We're gonna go over there, we're gonna measure them out, we're gonna see if we can get enough of them here quick enough. You're a lifesaver, man. I'm in with a shot again. This is me being happy. Thanks, Michael. We started this challenge, and I will not rest until I have the best chance of making it across. So this is that.
They cost nearly $18,000, but several weeks later, the batteries are installed. Delta is ready to go.
We've gone and done it. We've gotten ourselves the Tesla batteries. We have them now installed in the boat. I'm using 7 units on each side, so it's exactly well weighed out. These batteries get me in with a shot. I have enough energy that on a right day, and if all my other systems perform admirably, I have a very good shot at making it to the beach.
But all the testing has caused delays. It's autumn and the crossing is now much more risky.
There is some real danger involved, of course. It can be so wild there, it can eat ferries the size of, full city blocks. So we really do have to have good conditions.
Despite concerns, Arne is preparing to leave for France in just 12 hours.
I think he's ready for it to happen now, and he knows what he's doing. He's been thinking about this for years. Of course, there are dangers everywhere, but I just hope it's a good day and that it will cross as a hero. I'm going into labor in a couple of weeks, so, then there's a little baby who needs his attendance.
It would be wonderful to be here with you all day, but it's time to go off to work.
In Germany, Kalin Gulgang and the team are getting ready too. With the weather good, they want to fly the plane in the next few days.
So I'm getting inside, do all my pre-flight checks, and then I simulate a flight. Clear, prop?
The revolutionary new battery is fitted. Now, to see if it works.
I was looking on the window a little and saw
that the new battery is exactly 25 degrees, what is as expected.
But once inside the hangar, Stefan notices something unusual.
But there was a cracking noise and they saw some smoke coming up. The system is coming up properly. Both batteries are charged. Controller is coming up too. So almost everything is fine in here.
Yes, but you sure that was something, or?
Pretty sure, yes. It could be possible, but that's just an assumption. If there was some kind of dust getting into the charging plug here, then that could make this crack noise.
This time, the plane won't be flying over a lake. They'll be flying over mountains. To fly as scheduled, they've just 24 hours to check the data and prove it's safe. Coming up.
Are you ready? I'm ready. Go!
For both teams, it's their moment of truth.
Goes up.
Traffic out at sea, what can you do?
Right now, in with a shot. Gonna try and cross that English Channel within the hour. Do it full electric. Do it to show the world.
A cold morning in Calais, and Arne braces himself for his channel crossing attempt.
The most important thing is that we have relatively flat seas. I mean, I'm not worried about bouncing, but we need to be able to keep up the speed without me doing a nosedive into one of the, waves or such. So don't tell my wife I said that. Oh, man. Why don't weather reports get better as you get closer to the time? They always get a little worse.
I mean, it's not ideal.
It'll be a challenge. Me and my big mouth seem to have gotten me into a tight situation. I sincerely hope it calms down a little bit, because as I'm seeing it up close, this will just pound the CRRP out of the boat right now. I mean, it's some pretty rough, real ocean.
So here we go.
Okay.
Arne receives a briefing from the skipper of his safety boat, James Salmon.
What we've got to watch out for is we have the shipping lanes. This is the biggest catch for us. It's a bit like a motorway out there. Once we're out of there, we're free, almost home, okay? So we should have Dover in our eyes.
Yeah.
We'll zoom straight in through to Dover Harbour, home dry.
Yep, sounds like a plan, man.
You ready?
Yeah.
Let's go then.
Arne's plan is to cross the English Channel from Calais to Dover, maintaining a constant speed of 40 kilometers per hour for 1 hour. Any quicker or slower, and the batteries will drain before he reaches Dover.
Are you ready? I'm ready. Go! I'm holding a good speed. It's definitely bumpy, but about as good as we can expect.
Anne, ik moest je even vragen of je oké bent.
It's all A-okay here. If I'm good for you, I'm good for me.
It's quite rough, but it's doing okay.
Okay, we're gonna cut into the channel now.
Arne is nearly halfway across, but his route is now blocked by large cargo ships.
We're being held up by a big tanker.
Watch the waves of the ship, Arne.
Yeah.
One of the ships creates a 2-meter wave that dwarfs Arne's boat.
Good to go? Cost us some time and a lot of energy. Stop and start again. Hopefully it doesn't put too much in.
We need to go behind the ferry. We need to go behind the ferry. Slow down.
He's cut straight across our path.
Slow down and we'll make a new heading.
traffic out at sea. What can you do?
Speeding up again. We're speeding up.
It's gonna be hard to sustain speed with these big waves.
Suddenly, at full speed, Arna's boat has a complete system shutdown, just 8 kilometers from the Dover finish line.
I was whacking it so hard, we had a surge of power.
Yeah, that beep? So there's like a ground failure.
Arna is officially dead in the water. It's the day of the challenge. Test pilot Norbert Lorenzen begins his pre-flight checks on Kaelin's plane.
It's very important. If you want to convince someone about the new technology, you need not only to convince 100 people, 1,000 people, 10,000 people, 100,000 people, 1 million. You need to convince 100 million of people about the new technology. And we need records to demonstrate what's possible.
Kaelin's plan is for his plane, Electra 1, to be flown for a distance of 300 kilometers. Flying for approximately 2 hours, it will then return to base using only electric battery power.
It's a big challenge. Yeah, it's a long distance.
Everyone is nervous. We're making the last checks, looking that everything is all right on the plane, and yeah, so we're going ahead.
They haven't had time for a test flight. And despite yesterday's concerns, Stefan feels the plane is ready.
I told you everything about the techniques and electronics, so I have done everything I can do for you.
Perfect.
You have to decide now if you want to fly.
Okay, let's go. We can start. Aircraft is perfect. Everything was okay.
3 years after crash landing, Kaelin's hoping Electra 1 will prove batteries are the future.
Over the runway, okay? So you can flip to the right.
And goes up. The flight today is not for a normal pilot. We want to do a big step in the development of aviation. We want to write history. To fly with less energy, with clean energy, we change something big in aviation.
Pilot Norbert will be pushing both plane and battery, knowing an emergency landing this time will be over a mountain range.
That's good. Tango.
It's a new technology, and that's why worried about can happen. The engine is stopping. In that case, Norbert needs to make an emergency landing. If there is a battery failure, something is going wrong with the engine's power system, it's serious.
Approximately 8 kilometers off the English coast, battered by the punishing conditions, Arna's boat has lost all power.
The sea is a harsh mistress. Many a fortune was won and lost.
But he's not giving up.
Okay, we're gonna hardwire the plus and minus. Take a breath, get in there, fix it, go. There we go. Oh, man. This is perseverance, keeping going. 2 miles! 2 miles! God damn it, we're gonna make it!
With just a few kilometers left to the finish line and fighting against the waves, once again, Arne is losing power.
It's still moving, but I'm close.
But after more than an hour of pounding seas, detours and delays, a cold, wet Arne is finally forced to abandon ship.
You know, it's over 2 years that goes into something like this. A crazy idea that just snowballs into something larger than life and you can't stop it. You want something so badly, you know? You try and will it. A lot of things give, but in the end, it is or it ain't. So, it's pretty close though. It's beautiful trying. Life's all about trying.
In Germany, Electra 1 has been flying for over 2 hours and it should be coming into view at any moment.
I have some Bauchschmerzen, that means stomach. Butterflies, yes?
If it completes its 300-kilometer flight, Kalin believes the plane and its revolutionary battery will have shown the world.
I realized that an electric aircraft, we can do two important things. To fly with less emissions, and we can do in the same time, we can save money. We have this technology today. We don't need to wait.
We should be able to see them.
Modern electric engines, very light structures, and batteries. We need only to integrate these pieces of technology together like a symphony orchestra.
No.
So the result is a harmony.
Coming back, baby.
It's incredible. It's possible.
270 kilometers east of the airfield in Friestadt, the Kreisel brothers have heard the news.
Colin, he did it. Thanks. Good job.
A new type of battery powered an electric plane for an incredible distance of almost 300 kilometers.
Good guy, good driver. Today, we demonstrated that we can use this new technology, liquid cooling, for a normal flight. This is the future. We did history today.